Hey guys, welcome to the answer key to today's cube activity on probability. We're hoping it was a great review for your terminology to get you ready for your test on Friday. So if you rolled a 1, we asked you to compare. In this specific one, we asked you to compare theoretical and experimental probability. Now hopefully you remember that theoretical probability is in theory. It is something that is beforehand that you were predicting. Experimental is when you actually do. It is action behind it. Please copy theoretical probability is a prediction on what should happen by just looking at the item being discussed. Experimental probability is what does happen, so there would have to be data collected either from a list or graph of results of the exercise. Pause the video so you get the copy. If you rolled a 2, we're going to analyze the difference between an independent event and a dependent event. So just remember that an independent event is just that. They're independent from each other. One result will not affect the other result. Dependent means, well, it depends on what you got the first time. So if you happen to get an ace, there's less aces available. And the total amount of outcomes will be affected. So please copy. Independent events are when one result does not affect the results of the next possible outcome, meaning the denominators do not change. Dependent events are when you have to wait on the outcome of the first because the second results depend on what is remaining. Denominators will decrease by 1 each time. If you rolled a 3, we asked you to apply. So you had to roll the dice 10 times and keep tally of your results. Then you had to state your theoretical probability and experimental probability of rolling a 3. Now before you begin, you should know right away, theoretical probability is before you begin the tally. So before you begin rolling the 10, you could have answered theoretical probability. So in theory, you should roll a 3 1 out of every 6 times because there's 6 sides to a cube, and one of them are a 3. Your experimental probability will obviously vary per group because each group rolled the dice 10 times on their own and got all different variations of answers. And those possible answers are listed below. And of course, you could see they have varied depending on how many 3s you had rolled. Please pause the video if you need to check your answers. If you rolled a 4, you were trying to figure out what 30% chance of rain means. Now remember when we did this exercise in class, we had the dancing elephant for 0% and the sun rising equal 100%, and then the half and half, meaning equally likely right in the middle. And you want to find out where that 30% falls. So please draw this out. Of course you have 0% over here. You have 100% at the far end. Halfway in between would be 50, and between 0 and 50 is your 25%. Now if we look at this, the 30% is going to fall right past the 25. So impossible here, very unlikely, real close to 0. Unlikely, a little bit more. Possible, yeah. We're looking at possible, and then equally likely is the 50%. 50-50 meaning equal. The answer, of course, is possible, and I know y'all have all heard on the weather there's a possible chance of rain today. Now the second question is, what is its complement? Remember, its complement, they complement each other, meaning they make each other whole. Meaning if they're decimals, they're going to add up to 1. If it's a fraction, they're going to add up to 1. If it's a percent, the whole is 100%. So the complement is 70%. Okay, number 5, we asked you to argue for or against. We gave you a word problem, and it's asking, hey, is Lori correct? You're telling me if she's correct or not, and you're explaining. My explanation will be my proportion set up, part over whole equals percent over 100, and get the solution and see if it matches Lori's. Okay, so when I set up my proportion, I got my part, what I'm looking for, out of the whole. It says out of 600, so that means it's underneath the fraction bar, equals percent over 100. Cross multiply to solve, I just use scale factor of times 6. So 9 times 6 is 54, and add that 0. So I know Lori is correct. All right, if you rolled a 6, we ask you to describe. And that means it's a sentence again, and you're going to explain why a spinner can only be an independent event. Okay, so hopefully you resorted back to your definition of an independent event and compared it to dependent. Independent is a standalone. One spin will not affect the outcome of the second spin. So think about it. If I spin and I get this section right here, this slice of pie, that slice of pie does not disappear. So when I spin it again, I can still have this same outcome on the second time. Now there will always be 8 possible outcomes that will never be reduced to 7, because again, I could land on the same slice of pie anytime. Okay, so pause the video and copy. It can only be independent because the spinner will always have 8 possible outcomes, and you could land on the same section repeatedly, meaning one outcome will not affect the other outcome. All right, I only gave you 1 die, so there's only 6 sides on it, so the probability of rolling a 7 does not exist. It is 0, so you'll have to earn that free homework pass another way. The other possible way to earn that free homework pass is to make an A, meaning a 90 or above, on the test the first time around, and you will get a free 100 applied to your lowest homework grade on probability.